So here I copy pasted the solution that we had to the problem statement, at least not the solution, the problem statement for the example that we solved with two assets. In that case, we decided to call those assets, instead of calling them asset 1 and asset 2, we decided to call them bond and stock. So we have a bond security and a single stock security. The average return for the bond was 12%. The standard deviation of the bond, the riskiness of the bond, was 5%. The return of the stock was 20%. The standard deviation or the riskiness of the stock was 10%. We were also given that their correlation coefficient between them was 0.25. Given that, we wanted to construct a portfolio with a maximum return. Maximum return satisfying these two conditions. One of the conditions was obviously the fact that the proportion of the bonds and stocks should add up to 100%, meaning we're only investing in these two securities. Another condition that we mentioned was that the proportion invested in each security should be greater than or equal to 0. And lastly, that the variance of this portfolio, that's what this product is, the variance of this portfolio be less than or equal to 0.005. And in case you are wondering where we got that number 0.005, obviously this is given to us, but just for the record, remember that variance is just the square. Let me remind you, variance is the square of standard deviation. So as a result, looking at the bond variance, the bond variance as a result is just equal to the standard deviation is 0.05, but I can just go ahead and square it. So the bond variance is 0.0025, and the stock variance is 0.1 square, which is 0.01. So what I wanted was somewhere in between. In terms of riskiness, I want to construct a portfolio with a risk which is somewhere in between. 0.005 is somewhere between these two, twice as much as the bond variance, but half of the variance of the stock. But at the same time, I want to benefit from diversification. So given that variance, 0.005, what proportion of my portfolio should be invested in bonds, in that bond security with these two features, and what proportion of my stock investment should be invested, of my portfolio should be invested in that stock security. So first things first, let me just go ahead and copy the givens again. So givens, so it's nice to be organized, I guess. So the bond security and the stock. So we are told that the return for the bond is 0.12, and the return for the stock is 0.2. The standard deviation for the stock is 0.05 or 5% if you want, and the standard deviation for the stock is 0.10. There you go. So far we know these are the givens. Oh, sorry, we're also given the correlation coefficient, right? So the correlation between them is 0.25 positive. Awesome. So these are the givens, and in fact, let me just go ahead and highlight them maybe in yellow, because those are the givens. There you go. Now we want to construct a portfolio, right? Before we can construct a portfolio, we need to come up with this variance covariance matrix, right? Matrix. So how do we come up with that matrix? There are multiple ways. During our Zoom session, I think I provided you with one method, but basically using the definition is the key idea, is to come up with this, because ultimately variance is a property of deviation, right? The deviation of return from the mean. So you can come up with using the definition, come up with the result. Alternatively, I will do the following, which kind of makes sense, I hope, is that the variance covariance matrix will end up being a 2x2 matrix. The diagonal will be the variance of the bond, and then the variance of the stock. But the variance of the bond is easy to calculate. It's just the square of the standard deviation, that number. And the same thing for the variance of the stock. It is just the square of the standard deviation. So, which is exactly this statement, right? So the square root So variance is the square of the standard deviation versus standard deviation is the square root of the variance. All right, so we still need those two entries. Because it is a symmetric polynomial, if I find one, then the other one will be exactly the same as the other one, right? So I can just say this one is equal to that, that number over here. All right, so all I need is this number, which is, I gave you the formula last time, it is just the product of the standard deviation times the standard deviation of the stock times the correlation coefficient between them. There you go. So this is our variance covariance matrix. So this was an intermediate calculation, not necessarily given to us, but we were able to derive it. So let me maybe color it in orange. There you go. Now we are in a good position to start constructing the portfolio. Now construct portfolios. Construct portfolio basically means find the weights, right? AKA find weights. Well, the weights that we are so let's name the portfolio. The weights that we have is WB, W_B, and W_S. So we want to construct a portfolio which will have the sum of the weights should better be equal to 1, right? So let me construct a new column here, and that column is just the sum of that number plus that number over here. In fact, you know what? Let's start with just a generic portfolio. Let's call it, I think, folio. It's a good exercise. Let's call it portfolio 0. That's not the answer to our given problem, but I just want to have it just in case, just to test it. How about a portfolio which is consisting of 50% of my funds are invested in bonds and 50% invested in stocks. Basically, if you have a $1 million investment portfolio, half of that investment portfolio is invested in bonds and the other half is invested in stocks. All right, so this is a generic thing. So what I will do next is to calculate the portfolio return. And actually let me move this up a little bit. Okay, there we go. Return. So this is the return for the portfolio, and then the portfolio standard deviation. There you go. So the portfolio return, let's just use directly the matrix notation. Before I use matrix notation, let me do a couple of things. So this return row here, I'm going to name it, and we remember how to name objects, so we can call it mean. The average, right? So enter. This is the standard deviation vector. So standard div. Okay, so I want to make sure. Yeah, it's a unique one. Stadiv. Okay. In fact, let me just go ahead and whatever name that I gave to them, let me just write next to it. So I called that one as mean. This one I called it as div. If I remember it correct, let me check. Oh, I capitalized it. Let me just do it lowercase, actually. It's so that there is no confusion. Let me press enter. There we go. So it's lowercase. Next is I want to name this variance covariance matrix. Okay, so I'm going to call this V only. All right, because apparently I used the letter VCV for another file. So let me just go ahead and call it, or variance covariance. VC. Let me call it VC. Enter. All right, there you go. And so that I don't forget, let me VC. There you go. Awesome. What else? Okay, I'm then going to call this portfolio, the first weights here, I'm going to call it weight 0, enter. Oh, sorry. I think that one is already taken too. Let me just call it W0, I guess. W0, why not? Enter. And then I'm going to construct the second portfolio, which is the one that, you know what, it's going to be confusing, all these different portfolios. Let's just have one portfolio, and it's just W0, that's it. Let me just make a change here. There you go. So this is my starting point, but that's not the answer, obviously. All right, so now that I labeled all of them, so this one I called it W0, right? Let me, so that I don't forget, let me just put it here, W0. There you go. So I know the name of all of these things. In fact, let me just go ahead and put them, oops, not here, but here, like that. So inside boxes, so it will be easy to, oops, I keep doing the same mistake. There you go. Inside the box here. And then this one has a box. and this one has a box around it as well. So those are all inputs that will be used one time or another. All right, so how about the portfolio return? So it is just a product of this thing, the weights and the returns. So this is expected return of the portfolio, average return, right? Multiplying the return of the bond times the weight plus the return of the stock times the weight. However, because this one is a 1/2 matrix and this one is a 1/2 matrix, you cannot multiply two 1/2 matrices. So I can multiply one and then the weight should be transposed, or the other way around. So either I can start with the weight, so it's just W0, that was the weight, right? And then, oops, oh sorry, I messed it up. Okay, how did I manage to do that? Okay, got it. All right, so just delete that. Okay, so somehow I messed up my screen. Okay, just get rid of all this. Let's do it again. So this is equal to, what did we say? It's going to be the weight, W0, and times the return. I need to take a transpose. So transpose of the return. So you can check on Google what does it mean, the transpose of a matrix. Oh, that's the mean. Yes, I forgot that we named it, right? That's it. So, and then I can either press enter. Wow, so how did I mess up here again? I think it automatically completes the picture. Oh my gosh, what am I doing? This is a matrix multiplication, right? Holy, the machine is trying to correct me. Multiplication, oh my goodness. All right, so now it goes. So we want to multiply this matrix, which is W0, comma, the transpose, oh my goodness. All right, transpose of the mean, right? So I can either select it or you see how the name shows up. All right, close the parenthesis, then close the parenthesis one more time. And now you can either say Control Shift Enter. Usually it's recommended whenever you use matrix multiplication to do that calculation. Control Shift Enter. There you go. So that's the portfolio return. Let me add a couple more decimal places of accuracy. First, let's put it as a percent and then add a couple more decimal places of accuracy. So right now, because we have not done the optimization yet, all I'm doing is just writing the formula. And if half of the portfolio is invested in bonds and half of them is invested in stocks, I will get the average of these two numbers, 12% and 20%. The average is 16%. Okay, how about the riskiness, the standard deviation of this portfolio, right? So the portfolio standard deviation is, we need to use this matrix notation, which is pretty good. We need to multiply three matrices back to back. So the way it will happen is we will first multiply the last two, and then the outcome, we will multiply it with the very first one. So multiplying the last two, so that variance covariance matrix will be multiplied with the transpose of the weight matrices. I call it transpose because it's vertical. Do you guys see that? This one is horizontal. The given that I have here is horizontal. That's why I need to write it in vertical form. All right, so it will be in two steps. Matrix multiplication of, ultimately we will multiply the weights, W0, with the outcome that comes out of the product of the last two, right? The product of the last two will be just VC, comma, the transpose of the weights, right? So transpose of the weight, which is W0. Does that make sense? Close parenthesis, the transpose parenthesis, close the second matrix multiplication, close the whole thing. 3 times I needed to close the parenthesis, and then Control Shift Enter. All right, so I was supposed to close 4 parentheses. You kidding me? Oh, I added a redundant parenthesis somehow. Okay, I accept. Yes. Is my calculation so far correct? I want to believe so. No, it's not correct. I forgot to take the square root of the whole thing because this is just the variance. What I got, this thing is the variance I mentioned during the, so let me just go back. Yeah, so first of all, let me just get rid of that extra parenthesis, which was redundant, this one. That one is also redundant. And secondly, I want to add that square root expression now. Okay, there you go. I want to take the square root of everything. So as a result, I need to add one last thing. All right, and then Control Shift Enter. There you go. Okay, that's pretty good. So this is the standard deviation, the square root of the variance. Awesome. Well, now our objective. Okay, now we take it seriously. We want to maximize this number the expected return of our portfolio. This is the portfolio return and the portfolio standard deviation, right? Let me just go ahead and maybe color it in green. There you go. So that's what we want to do. We want to maximize the return such that these two, they add up to 1. So I want to make sure they add up to 1. And secondly, this number be less than or equal to 0.005, right? Well, actually not exactly. So we want the square of this number to be less than, okay, let's put another thing here because it's confusing. Variance. The variance of the portfolio is just equal to the square of this number squared, basically. All right, this number. So we want this number to be no more than 0.005. Which way is it easier? You know what? Let me just do the following. Let's just get rid of this. Let's put that as an additional condition here. So we want the variance to be, let's put it right here. So the variance is 0.005, but that implies that the standard deviation, which is the square root of this is what? 0.070711. So standard deviation should not exceed this number. So the sum of the two should be 1, and then the standard deviation of the portfolio should be less than or equal to this number instead of this. If the variance is 0.005, if the variance of the portfolio is to be less than or equal to this, it means the standard deviation of the portfolio should be less than or equal to this. Perfect. Now the units are comparable basically between this and this. So right now we still have some wiggle room to increase standard deviation a little bit more, right? Because right now if 50% is invested in bonds and 50% is invested in stocks, I mean, it seems we're not there yet, right? So we can take a little bit more risk. For instance, if I were to increase, so let's decrease this one to 0.4 and increase this one to 0.6. So what happened is the return went up. It used to be 16%, now it's 16.80%. And besides, we still have some room to move, right? I can further decrease this one, maybe 0.38, I guess. And this one is 0.62. The sum is still 1, which is good. How about the standard deviation? Oh, we still have some moving room to move. So do you guys see what's happening? The return kept increasing again. We want to find the maximum return. How about 0.36, 0.36, and 0.64? Even now we are within the limits. Okay, how about 0.35 and 0.65? Now we exceeded the limit. So do you guys see what we're doing? We're trying to find the right amount, the portfolio, to construct a portfolio such that the standard deviation does not exceed this. And we realize there's a trade-off between return and standard deviation. The higher the standard deviation, the higher the return. But because I'm told that my standard deviation cannot exceed this, I need to stay within my boundaries. But we know how to solve this problem very efficiently using solver, right? So we go to data ribbon. And then from there we find solver. And now we want our objective. So, well, our objective is first we want to have this maximized by changing, we want to change the weight of the portfolio, namely these two, right? So keep changing those two. Okay, now what are the constraints? First of all, we want the things to be non-negative. So we are not allowing for short sale. If I uncheck this, negatives are also allowed, which means you can short sell securities, basically. But by checking this, I'm saying that, hey, I want to invest in positive amounts in bonds and positive amounts in stocks. But I still need to add some constraints. The constraints are that the sum of the stock and bonds should add up to 1. Let's quickly add that constraint first. So the reference cell is that sum here better be less than or equal to 1. Or if you want, you can say exactly equal to 1, right? So that makes sense, equal to 1. So this number should always be equal to 1. Say OK. And then I want to add the additional condition, which is the important condition, namely that this standard deviation never exceed this number. So our standard deviation, which there's a formula underneath it, right, is less than or equal to this number. Does that make sense? Press OK. And that's it. Now we are ready to say solve, and hopefully press OK. Wow, Look at that. And by the way, we were extremely close, right? Earlier when we said we guessed 0.64 and 0.36, but this is an exact calculation. So it's the recommendation, the policy recommendation is to invest 35.96% of our portfolio in bond and 64.04% in stock. And as a return, we will get this much return on our investment. And besides, the risk we are taking is exactly the risk that our client told us. The client said, I don't want more than this much risk, which is in terms of standard deviation. In terms, if you convert it into variance by just squaring this, it's exactly 0.005. And still respecting the constraint, we are able to construct a portfolio with an expected return of 17.12%. And that's it. So that's how we would solve this problem with 2 assets using Microsoft Excel. So in the next exercise, I will be solving a problem with 3 assets, all right, using Excel. Hope to see you guys in that problem.